So this is a series on solving systems of equations. This is part 3 of a 4-part series, and in this video we're going to talk about solving systems of equations by substitution. So we're going to be solving this particular equation, and we'll do one more on top of it. Just remember that a system of equations is a set of equations with the same variables, so both x and y in this case. And that solving a system of equations means that you are finding one or more solutions that make the equations in the systems true. So an x that makes this true, and an x that makes this true. So an xy combination that make this true, and an xy combination that make this true at the same time. So, solving with substitution, we notice, I hope you see that this has y as an equation is equal to some other stuff. And this also has y. We're trying to make sure that those are the same y's. So what I want to do is take this stuff that's equivalent to y and actually get rid of that y and replace it with the new stuff. So we see 5 times negative x minus 7, I'm replacing the y with the stuff above, plus the 3x from before. Plus 3x equals negative 13. And now we're going to solve this like you would solve any one variable equation. We have to distribute, so negative 5x plus 3x equals negative 13, and we combine like terms, so we have negative 2x minus 35 equals negative 13. I'm going to add 35 to both sides, and negative 2x equals 22. We'll divide both sides by negative 2, so x equals negative 11. Now we are not done yet because remember, a solution to a system includes an x value and a y value. And right now, we only have an x value. So our x value here is negative 11. And what we need to do is we need to substitute it back in. So I'm going to take the equation that we started with, which was y equals negative x minus 7, and I'm going to substitute the x value of negative 11. So y equals negative, and x we know now is negative 11 minus 7. So our y value is 4. And this is the solution as an ordered pair of the system of equations that was presented in this problem. Go ahead and pause the video and try and apply some of the same things that you've done in the previous part as you explore this new type of problem. Remember, you're substituting a variable with the stuff that that variable is equal to. So you're replacing a variable with an expression. Pause the video and try it out. Hopefully you've had a moment to try this one out. It looks like we've got x equal to a certain value, and that's really important with substitution. We need a variable all by itself equal to something else. So this x in the first equation is going to go out. I'll do that in red. This equation's going out, and this is replacing the x value. So we've got 2 times the stuff that replaced x, 3 minus y, and then the rest of that original equation. So it was 2x plus 2y equals 18. Well, now it's 2, and what was x, plus 2y equals 18. Now we've substituted, we're going to solve. We reach a point that makes something that's not true. When we reach something that's not true, we say this has no solution. And if we were to graph it on a grid, we would notice that these two lines never cross. So it's really important to pay attention. When you get something strange like this, it means there's no answer. go ahead and practice the videos. Substituting is the most important part, and then you'll solve for x and y. Review this video if you have questions and need another view it as an example.